In this video, I would like to talk about this power supply. I have talked about this one power supply in my previous video, and this one is the same, just that it claims 150 watts, 12.5 ampere. So let's open it. This is the power supply. You can see the transformer from this side. If I open this one again, this one just really supplied 12 volt 1 amp because the chip in it can only handle up to 12 watts, which is 12 volts 1 amp. This one says this is for 12 volts, 12.5 ampere, 150 watts. Well, in this side, this seems to be the primary with the primary smoothing capacitor, optocoupler, secondary smoothing capacitor, which is going to be the same rating, maybe 1000. Okay, so it is 1500 microfarad 16 volts capacitor. There is this optocoupler, maybe or may not be a safety capacitor between primary and secondary side. A bridge rectifier here, bigger one, bigger smoothing capacitor, 22 microfarad, a slot for it, some induct resistor thing, and DC thermistor. Is this the transistor, or is this the diode, or transistor and a diode? Well, I have to unscrew it to take a look at it. But before opening this further, let's also compare it with a real or a bit bigger power supply, and can give you about 12 volts 10 amp. And in comparison of this one, this power supply is really big. You can already see how small the transformer is in this one and how big the transformer is in this one. There's two capacitors in parallel, but they are kind of irregular. There's discrete diode for the rectification, interference filtering, and a fuse. There are these two transistors, they are in parallel to switch the transformer, a single diode for the rectification. There are many capacitor and an inductor for smoothing. But this one just looks quite tiny, and you can see the wire, the secondary winding wire, and if it is really meant to supply 12.5 ampere, the wire will get very hot. It will melt the housing of the transformer, and it will basically heat up and basically destroy the lacquer on its wire, and it will short the primary and secondary, and it may blast, evaporate in this process. I guess this power supply can give you about 12 volts 5 ampere, or maybe 12 volts 2.5 ampere. I have removed the screws and I can take it out somehow. You can see the isolation here, isolating distance, or the gap between the primary and secondary side. And this seems to be the switching transistor for the transformer, and this one seems to be the diode for the rectification, two diode in single package. So this one can give you about 12 volts 5 ampere, but the transformer will get a bit heated. There's also no fuse, no fusible resistor, induct resistor, so you just rely on the mains breaker, which is quite slow. And they did put some heatsink. It spread for the diode but didn't spread for the transistor, so I have to put my own heatsink compound. Well, I can't wait for my breaker to open, so I've connected a fuse from my side, and the only thing that can draw over 10 amps is my inverter. So I've connected my inverter here and I'm measuring the current, and I can slowly increase the current from 0.6 ampere to 10 ampere or even more. We don't care about the inverter, we care about the current and later voltage. So let's try to power it, and of course hope for no explosion. So let's power it now. No explosion. It draws around about 0.7 or 8 amps. Now we'll increase the power a little, 1 ampere to 1 ampere, 2.567, and it cycles now. So actually this one is also a fake one, or maybe not a fake one, but the current is definitely not 12.5 ampere, but it is just 2.5 ampere. And of course I was right that the transformer may be rated for 2.5 ampere and maybe 5 ampere, but it is just rated for 2.5 ampere, and this one can only supply about 12 volts, 1 ampere. So they have changed the marking a lot to sell more. Well, I've drawn this schematic, and it is just a simple power supply with a chip. You can see the tiny chip here, and I would say a bigger distance between primary and secondary side would have been appreciated, but anyways this somehow works. And this is the circuit. This chip does the voltage sensing. The voltage sensing is done on the secondary side with the help of this TL431 and some resistor divider, and of course there is a dot here. There is this resistor which passes a constant current to keep the reference operating, and when this pin of the TL431, which is called the reference pin, reaches 2.5 volts, it will pass much more current, and this phototransistor inside the optocoupler will start to conduct, and it will glow, and this transistor in the optocoupler will turn on until the chip the voltage is enough, reduce the duty cycle, and it will start to regulate the duty cycle. And looking at the circuit, it seems that the power supply is or may be designed by a professional, or they may copy the schematic, and if they are copying the schematic they are way much ignorant to ignore the fuse and the interference filtering. There is no fuse and fusible resistor and no interference filtering except this tiny cheap capacitor. There is no fuse, just traces going from live and neutral. So this is just going to be dangerous. This transistor can fail and it may short, which is 100% or maybe 50% guaranteed. So when this fails short circuit, then there is the DC resistance of this coil in the transformer. So what happens is that the full current flows through the coil of the transformer, through the winding of the transformer to the ground. This resistor will immediately blow up, the transformer will immediately blast or blow up, and in the process it will also damage the load, or it may not have enough time to damage the load, but a fuse may have been appreciated if it was there. There is a snubber network with a 96 kilo ohm resistor, and it protects the transistor from over spikes or over voltage spikes. The chip turns on via this very high resistance resistor which charges this capacitor, which is 10 UF, not 0 UF. When this capacitor charges, the chip starts to switch, and when this MOSFET is on, the polarity of the transformer is this, and the polarity of the secondary winding is this, and this is the primary winding. So this diode and this diode are not conducting, and then the chip turns off, and it makes a pulse, so the polarity of the transformer flips. This diode and this diode can conduct, T3 diode can conduct, and the voltage will also flip here and here, so this diode will charge this capacitor and power the load, and it will turn the regulation circuit on, and this can further maintain the cycle. They will regulate the voltage up to 12 volts. I hope you liked the video, and thanks for watching the video.